Hi everyone. Today I'm going to discuss circle and its parts. The circle is one of the most common geometric figures of all. It's very simple. This is just a set of points which are all the same distance from a given point. However, it is also a highly complex math concept. Despite its apparent simplicity, the properties of a circle and its part cannot be visualized as easily as a square or a triangle. Now, circles can be seen everywhere. So some of these figures, like this Ferris wheel, wall clock, are associated with circle. So when we say circle, it's a curve composed of all points on a plane which are at a predetermined distance from a fixed point. Now, class, this fixed point is we call as the center of the circle. Okay. So we will be dealing with the parts of the circle. So let me label the points on the circle here, and we will make use of this as our illustration to define some parts of the circle here. So we have, let us call this circle as center O. So we have this point I, J, K, L, M, N, O here. So if I'm going to name some chords here, and we name the chord using the endpoints, and these chords are all line segment. So we have line segment HB here, line segment HF, line segment BD, line segment GE. Line segment AE is also a chord, as well as line segment GC, and many more. So looking at the endpoints of each chord here, for example, HB, HF, BD, all these endpoints lie on the circle. So meaning we define a chord as a line segment whose endpoints lie on the circle. Now, when we say diameter, so we can get sum from the chord as diameter 2. So we have line segment GC, line segment AE. Okay, we also have line segment BF, line segment HD, and many more. And the endpoints of each diameter here also lie on the circle. But another thing here, each of these diameters or each of these line segment passes through the center. So we define diameter as a chord that passes through the center of the circle. Okay. For the radius, so we have line segment OB as example of radius, line segment OC, line segment OA, line segment OH, and many more. So we say that radius is the distance from any point on the circle to its center. So we can say also that all or radii, which is the plural form for radius, of the same circle are congruent. So meaning all these radii of circle O are equidistant or congruent. Okay? So they are equidistant. Now, as regards to circumference, so this is the counterpart of perimeter for other polygons. And we define the circumference as the distance around the circle. Okay? Now, we go with angles of circles. So let's label this again. B, C, D, E, F, G, H. And then let's name that as circle O. So we have I, J, K, L, M, N, O, P, Q, R, S, T, U, and V. So for central angle, we can name some central angles here. And to name some, we have angle AOB, we have angle BOC, we have angle COD, we have angle DOE. Another one, we have angle EOF. Now, an angle, guys, again, is composed of two rays with common endpoints, and that common endpoint is we consider as the vertex. So, as regards to the example here of central angles, and each angle here has the same vertex, and that vertex is the center of the circle. So, we define a central angle as an angle whose vertex is the center of the circle. Okay. Now, while this is inscribed angle, if we're going to name some from circle O, we have angle AGC. We also have angle PFD. We have angle AEC. We have angle DFB. So these are all examples of inscribed angles. And if we're going to look at the vertex of each example inscribed angles here, all these vertex lie on the circle. So we define an inscribed angle as an angle whose vertex lies on the circle. Now we have minor arc, semicircle, and major arc. So if these are points A, B, C, D, E, F, G, H, and let's name this again a circle O. So minor arcs, guys, to name some, in circle O, we have arc AB, arc BC, we have arc CE, we also have arc HF, one more, we have arc FD. So for example, arc AB, so this arc AB, guys, is intercepted by angle AOB, which is a central angle that measures less than 180 degrees. Okay, so meaning another is BC. This is intercepted by angle BOC, which is a central angle that measures less than 180. So meaning this is intercepted by, so this is any part of the circumference of the circle intercepted by a central angle measures less than 180 degrees. For semicircle, we have semicircle HBD, semicircle BDF, semicircle EGA, semicircle GAC. And in comparison to minor arcs, we name a semicircle as well as major arc using three letters, such that the first and the last letter are actually the endpoints of the arc. And then the middle letter is the point within the endpoints of the arc. For example, HBD. So if we're going to add like A E D AEB, if we're going to add AEAB as ano, so if we're going to add like a later, no? So this is an example of major arc, but let's concentrate with semicircle. So HBD, so we mean this arc, okay? And then BDA, so this is from here until BDF, no, BDF until here. So as you can see, the semicircle, so this is intercepted this time by a diameter. Now we have major arcs. So major arcs, with major arcs, we have arc AFB, we have arc BDH, we have major arc HEC, another major arc, we have major arc GCE. Now, working on arc AFB here. So we have arc AFB. So from here until here. Now, this is a major arc and we have majors of three letters such that the endpoints AB are the first and the third letter, while the middle letter F is any letters or any points within point AB. So the reason why we are using three letters for major arc as well as with semicircle, while we only use two letters for minor arcs, if we just make use of one letter, for example, arc AB, we do not know as to we are referring to this arc or this arc, minor arc AB. So just to differentiate the two, we have to add one more letter or one more point to differentiate a major arc from a minor arc. And we define a major arc as any part of a circle. So major arc is any continuous part of a circumference of a circle that is intercepted by a central angle measures greater than 180 degrees. Okay. Now here, let's name some radius. So we have if this is point A, B, C, D, E, F, G, H, and then we name this as circle O. So this is I, J, K, L, M, N, O, P, Q, R, S, T, and then U. So for radius, we have line segment OA, line segment OB, and line segment OC. So the endpoints of this radius is the center and any point on the circle. For diameter, the diameter passes through the center and the endpoints are on the circle. So to mention some, we have line segment AE here. We have line segment GC. We have line segment BF. And then for chord, we have line segment AG. We have line segment AC. We also have line segment CE. Inscribed angle. So the vertex is on the circle. So we have angle AGC. We have angle BFD. Another, we have angle BDF. For central angle, so the vertex is the center of the circle. We have angle AOB. We have angle BOC. We have angle COE. Minor arcs. So minor arc is continuous circumference, continuous part of the circumference of the circle, which is intercepted by a central angle that measures less than 180. So we have arc AB, arc BC, and arc CD, and many more. Major arc, on the other hand, is any continuous part of the circumference of the circle, which is intercepted by a central angle measuring greater than 180. So we have arc ACF. We also have arc BEH. We have arc BFH. For semicircle, so we have arc ABE. We also have arc FHB. We have arc GAC. So we're done with the parts of the circle. We have made use of some illustrations for us to define each part of the circle. Next meeting, I'm going to discuss some properties of a circle as what I've mentioned. And before I end this lecture video, I'd like you to work on the definition of each term. So you select 3 terms out of this 9 terms, and then you define in your most simple definition as how you understand each part, and then you write your answer in the comment section of this lecture video. So goodbye for now.